Welcome everybody. Welcome to the second meeting of the mead exam prep course. Today we're going to talk about mead making, the mead making process. We're going to focus today on traditional mead. All of the melomels and metheglins will be discussed in the next meeting. So this is our meeting course layout. This is going to be the second meeting out of the course, in which we will discuss ingredients in the mead making process. This is today's outline. We're going to first discuss ingredient selection, then the basic mead making process, and then optional processes in making traditional meads. So let's dive into the first section of the presentation today with the ingredient selection. So mead is obviously made from honey, water, and yeast. And so we first have to discuss honey, of course. So honey is the main flavor of any traditional mead, always. It is the single sugar base of which the yeast metabolize and create alcohol. So honey is obviously the main flavor of any traditional mead. So if we want to create a successful mead, we would like to start with fresh honey that went through the least amount of processing. Sometimes honeys are being boiled before they reach the customer. So try and get the honey that went through the least amount of processing. Honey is also best stored cold to reduce enzymatic action and prevent the degradation and color changes. So honey that is aged and oxidizes has enzymes in it that make it crystallize and also make its color much more dark. Also select the honey for the type of mead that you're going to make. And you can use the honey references on the BJCP website, although these really focus on US honey varieties, but maybe we can create some more of our own honey expressions. I'm sorry, honey descriptions to use. So that way we select the honey. The next ingredient is going to be water. So we need a good source of water that is critical for any good mead. So same as beer, if the water is good for drinking, it's probably good for mead. We want water that is clean, tastes good, and is free of any chlorine or bacteria, and all of these will work well. Do not use water that were processed through a home water softener because this sometimes leaves a salty taste in the mead. And also avoid water high in minerals or containing any iron. This could make off flavors in the end product. The next ingredient is going to be yeast. So when we evaluate which yeast to use in any mead, we need to consider the following characteristics. First of all is the fermentation flavor profile, then the yeast alcohol tolerance, because mead is a high gravity drink. So we need yeast that are more tolerant to alcohol. The temperature range that the yeast work in. So if we don't have a home fridge, we need to use yeast that can work with less off flavors in higher temperatures. Then we need to know the nutrient requirements for the yeast. Honey is notoriously known for having really low amounts of nutrients for the yeast. And also the yeast flocculation, we would like yeast that flocculate well, so that we don't have to do many rackings to clarify the mead. Almost, I'm sorry, but almost most mead makers will use wine yeast strains, mostly champagne yeast strains, which are high tolerant for the alcohol. And we know how to work with them in the temperature ranges and their nutrient requirements. So that's for the yeast. Then the last thing, because honey is notoriously deficient in nutrients for fermentation for the yeast, we usually have to add some yeast nutrients as additives. So we usually need to add nitrogen and phosphate, which the yeast need to build proteins in order to metastasize and create more cells. If sufficient nutrients are not available for the yeast, the fermentation will be sluggish and slow, and the mead will have off flavors that usually will take a long time to age out, like fusel alcohols and esterification and other stuff like that. And also, when to use these additives is just as important as the types of additives to use. We will discuss that in the next in the presentation. And usually the additives we will use in mead will be GoFirm, which are vitamins, minerals, and amino acids for the yeast for the rehydration process. Then we're going to add some diammonium phosphate or DAP, which provides the nitrogen that is necessary for the yeast to grow and for proper fermentation. And then we have the Fermed K, which also provides nitrogen, key vitamins, and other nutrients, and also inactivated yeast cells for the yeast to consume and create more yeast membrane, cell membranes. Then the last one will be potassium carbonate or potassium hydroxide, which are minerals that play a role in buffering the must and keeping the pH not to go too low, so that the yeast can actually develop. Okay, so more additives that we can use, and these are mostly for balancing the mead. After fermentation, so we have an acid blend, which is a product that is made from a blend of citric, tartaric acid, and also malic acid, and we use this acid blend to balance the mead at the end of after the fermentation. Then we have grape tannin, which is derived from grape skins, and it adds tannin. Pectic enzymes, pectinase, which is used in some melomels to reduce pectin haze. Potassium sorbate, it's a commercial food preservative used to inhibit mold and yeast growth. So if we want to inhibit bacteria and yeast, we can use potassium sorbate. And potassium metabisulfate, which is added before fermentation to kill off any wild yeast, or after fermentation to stabilize the mead, so that it won't change rapidly due to oxidation. So these are all of the ingredients that we usually use in a traditional mead. And now we will discuss how the basic mead making process, or basically how do we make mead from these ingredients. So we start from the ingredients. So what we're going to describe now is a method of making 5-gallon semi-sweet traditional mead. But we will discuss when fruit or spices would be added inside this method, but next time we will discuss it in depth. So for the ingredients, we're going to need an 8 kilogram of wildflower honey, 4.5 tablespoons of GoFirm, 1 tablespoon of Fermed K, 2 tablespoons of DAP, diammonium phosphate, 2 packets of Lanolin Narbonne 71B1122 dry yeast, which are basically champagne yeast, and 3.5 gallons of spring water. These are the ingredients. Now we're moving on to the equipment we're going to need for this method. So we're going to need a fermenter, a fermentation chamber, basically a fridge, a temperature controlled fridge, a hydrometer, a thermometer, stainless steel wine stirrer or degasser, and a drill to actually use it, a pitcher for yeast preparation, a must thief to test for the must gravity, and an airlock, and also an O2 kit. So what do we do? So first of all, we start with the must, with preparing the must, which is the wort for the mead. It's called the must in mead. So if we're using fruit, we will wash, chop, and freeze the fruit ahead of time and thaw before using. The freezing will make the fruit cells to burst, releasing the juice as it thawed. And then we will combine the Fermate K and DAP inside one little plate, and warm up the honey by putting the containers in hot water. As you can see, I used my sous vide maker to warm up the honey and make it less viscous, and sanitize the fermenter, the carboy, or the bucket, or the demijohn, whatever you use, and all of the equipment you're going to use, the wine degasser, the steering spoon, the airlock, everything, okay? Sterilize everything. The next thing, after we sterilized everything, we need to prepare the yeast. So we start rehydrating the yeast in water with the organic nutrients that is the gopher. So what we do, we dissolve the gopher we're going to need in 1 pint of 43 degrees Celsius of water. And then when the temperature cools to 40 degrees centigrade, we sprinkle the yeast evenly over the surface of the water without stirring. We wait 15 minutes, we wait for 5 minutes, and then we stir, and then we wait for another 10 minutes, and then we can pitch the yeast into the must. So in the time that the yeast are sitting and preparing to go into the must, we can start making the must. So while the while the yeast is rehydrating, we combine the 3.5 gallons of spring water and the 18 pounds of 8 kilograms of the wildflower honey in the fermenter. Usually I measure the amount of the final the final amount of must that I want, which you can see in the stickers. So the upper line is where I want to get. It's the line of 22 liters. I measured it before. So I start and put some of the water in, then put the honey in, and then add some more of the water. And after we've added all of the honey and the water, we can use the wine degasser to mix and whip and stir and to perfect blend all of the honey and the water. This also, the mixture or the wine degasser is basically a long rod with paddles at the end. And then you attach it to a drill, and then it spins very rapidly and introduces a lot of oxygen into the must. So that's about stirring the honey and water. Before I bought this wine degasser, I had to take all of the huge demijohn and just shake it, which is really hard. I really recommend the wine degasser for that task. After we have mixed stirred the honey and the water, we need to oxygenate the must with pure CO2 or air. I have a pure CO2 canister that I use for this task. I just combine it into I hook it up into a gas stone, an aeration stone, put it inside the must, leave it. The length of time will depend on your oxygenation system. There are other systems that use air pumps with filters. Okay, you can order these from Amazon or AliExpress. They're really widely available. And you don't need to fully saturate the must with oxygen at this point, although it will be good for the yeast. But as you will see, we'll add more oxygen through the fermentation process. Then we're going to add at the beginning of fermentation about 3/4 of a teaspoon of the Ferment K and DAP mixture to the must, okay, which is basically 1/4 of the nutrients. We're going to add them at the beginning to the must. And after the yeast are ready, we need to put in the yeast solution into the must and stir again gently. So not to get the oxygen out, but only to have the yeast completely integrated into the mix. And then we install the airlock. This is how we add the yeast into the must, and we move the fermenter into our fermentation chamber, and we ferment at 18 to 21 degrees Celsius. And now after 24 hours, again after 48 hours, and again after 72 hours, we add each time 3/4 of a tablespoon of the Ferment K DAP mixture into the must, and we stir it into the must while aerating. And and if we were making a melomel, we also punch down the cap. So notice that we use a system that introduces more yeast nutrients every 24 hours during the first 3 days of fermentation, okay? And we also stir it into the must, and we also add air into the must every 24 hours for the first 3 days of fermentation. We'll discuss why we do that later in this presentation. And we ferment until the activity stops, usually between 2 to 3 weeks, actually, not less 1 to 2 weeks. It's a lot, the fermentation is a lot slower with mead most of the time. So that's for the fermentation management. Then to finish up, as we transfer the must into a smaller carboy after the fermentation stops, and we store it. We store it until it is sufficiently aged. And if we're using some herbs or spices, we usually add them now after fermentation. And we age it until the mead clears, usually between 2 to 6 months. And if the mead is not brilliantly clear after 2 to 6 months, we can add 1 package of super clear, which is an enzyme to clear the mead. Then the final stages will be to taste and adjust the sweetness and acidity, as we talked with the acid blend. And to sweeten, we can mix in some honey solution. And to acidify, we can we can use the acid blend and water to and mix it to taste. And if we want to stabilize the mead, we can mix some potassium sorbate inside to kill all the yeast and stop fermentation. And if we want to carbonate the mead after we've stabilized it, we don't have any more yeast, so we need to use a keg and do some forced carbonation. And in the end, we can package or bottle the mead in a keg or in bottles, and continue to age it as we desire, or drink it as it's bottled. So this is the really simple traditional mead making process. And now we will move on to discuss some optional processes of the mead making process. So there are several different ways people usually make must for mead fermentation. And some possible treatments that can be used include boiling, which is boiling the must, sulfiting the must, adding potassium sulfate, pasteurizing the must or the mead after fermentation, sterile filtration, okay, and the no boil or no treatment method. We will discuss all of these methods now. So we'll start with boiling the must. So the advantages of taking the water honey blend and boiling it is that proteins and other impurities coagulate and float to the top, and we can remove it, okay? And also we gain a better sanitation of the must in order to not have any wild yeast or bacteria. But the disadvantages of boiling the must is that all of the volatile aromatics from the honey, okay, all of the floral aromatics are basically driven off because of the boil. So some people will use a compromise, okay, so of these techniques. So most people would just briefly boil, okay, until the proteins coagulate, and then rapidly chill the must in order to have as little volatile aromatic compounds escape, okay, as little as possible aromatic compounds escape. But usually 15-minute boil that's required for sanitation is very harmful to the aroma and to the resulting mead. So usually we recommend not to boil the must. Using potassium metabisulfate is also a way to sanitize the must. So honey and water are mixed, then the must is then we add the potassium metabisulfate, and yeast will be pitched the next day. The advantages of using potassium metabisulfate is not involving heat, and so we don't have any aroma losses. And the disadvantages are that some people are sensitive to these compounds, and proper adjustment requires to know the pH and the scales, and it takes some equipment. And sulfites also tend to bleach fruit. So when we use fruits, when we make melomels, we don't add sulfite because it will make it white. And proteins are not removed, okay, in this way. So this is for potassium metabisulfate. The next thing is pasteurization. So to pasteurize, we need to bring the water. You usually bring only the water into a boil, and then add the honey, and then allow the temperature of the must to settle down until between 60 to 71 degrees. And this temperature is held for 15 to 20 minutes to ensure pasteurization. And then it is cooled rapidly to pitch the yeast. The advantages, it does not involve boiling the honey, only the water. So the aromatics are preserved, and sanitation will be modified in this method. But the disadvantages of this method is that proteins are not removed, and it's not as fast as the no boil method. The next method is going to be using a sterile filter, okay, which looks something like this. And then it filters all of the living cells from the must, and so it's basically sterile. The advantages, it removes all the proteins and the microorganisms. The disadvantages are possible loss of flavors and aroma compounds, and also body. And the cost of the equipment is usually very expensive. And also the filters themselves are usually expensive, and the time involved in processing the honey, it usually takes a lot of time because these filters are usually very slow, at least the home versions of them. So that's for sterile filtration. The last method of making must is the no boil method, which is basically the easiest method. You don't do anything. So this is the method I presented in the previous section as the basic technique. We heat the honey just to make it less viscous. We add it to the water, we mix it, and then we immediately pitch the yeast. The advantages is it has the fastest time, the least cost and effort, and we have a pure tasting results with all of the aromatics in it. And then the disadvantages are not removing the proteins and possibly worrying people about contamination. But because of the low pH, it will not contaminate. Published lab results tests have shown that preparing traditional meads must, without heat or sulfates, is capable of producing good medium for clean fermentation. And that's why the noble method is the recommended method. Now, let's discuss some things about yeast preparation. So we can pitch the yeast directly into the must, okay? We will just take the dry yeast and sprinkle them on top of the must, and then we stir it after 15 to 30 minutes. But it's really not recommended for dry yeast. You can do that with liquid yeast, but it's not recommended for dry yeast. And the reason is that the yeast granules are more prone to clump together and stick, and thus not work properly and not ferment properly. A lot of the cells will not ferment properly, and also the must might contain some sulfur dioxide if we added potassium sulfate. So it can, in this stage of the rehydration, it can kill the yeast. And the yeast are also severely stressed before they can reconstitute and build themselves together and prepare for fermentation. And some of their stored nutrients may leak and contribute to some off flavors in the finished meat. Liquid yeast can be added directly to the must, but with less impact. But for dry yeast, we really need to prepare the yeast for fermentation. The first method of preparing the yeast for fermentation is to make a yeast starter. So we start from a low gravity must, and then we let the yeast ferment, usually on a stir plate. And it increases the yeast viability, and it ensures that the yeast are properly prepared for fermentation. We can add more must with higher gravities as we go and prepare the yeast to be really active fermentation before we add them into the mead must. And the second method we can prepare the yeast for fermentation is to rehydrate them. So what we do here is we allow the dry yeast to reabsorb all of their cellular water before we add them to the must, okay? And it ensures that healthy cells will retain their fermentation characteristics. And also, if rehydration isn't carried out, the yeast cells can leak their cellular compounds through the membrane, and the yeast will lose viability, and the population will be unable to rapidly ferment the mead. The rehydration process usually takes about 30 minutes. Okay, so what we do what we do in the rehydration process is we usually allow the yeast 30 minutes outside of the fridge to come to room temperature. Then we use clean water, and water hardness between 250 and 500 ppm is optimal. The yeast will also take up a lot of micronutrients as well as water. That's why we usually add micronutrient blend to the rehydration liquid. Okay, so to make the yeast absorb as much micronutrients as they can. Use the proper water temperature. This is usually written on the yeast packages. It's usually between 37 to 40 degrees centigrade. And after 15 or 30 minutes of rehydration, we can pitch the yeast. The next thing I want to discuss is the nutrient additions. As we said in the beginning, we mix the ferment K, which is the brown stuff, and the diammonium phosphate, the DAP, which is the white stuff. So we mix them together in a bowl, And then we keep them until for the first 3 days of fermentation, and we add a quarter of the amount each time. So so about nutrients, we can add no nutrients. Okay, mead can be made this way. The yeast will ferment, but the results are likely to be inconsistent, take a long time to ferment, and also have a lot of off flavors. And also the second thing we can do is add all of the nutrients together at the beginning, okay, which it provides the nutrients to the yeast, but it doesn't deliver the nutrients when the yeast actually need them. So it can overstimulate the yeast and result in off flavors. And the yeast need the available nutrients through their growth phase. And so the last method we're going to discuss is staggered nutrient additions. So what we do with this method is that we add the nutrients basically in 4 doses, okay, all over the start of the fermentation, and allow the yeast to grow and build more yeast cells for the fermentation, okay? So instead of adding all of the nutrients together, the same amount is staggered over several times, usually 4 times. This method was developed by the commercial wine industry as a way of supplying the nutrients to the yeast when they're needed. And it's kind of a just-in-time delivery. And healthy yeast are essential for a clean fermentation, and with less chance of off flavors. Okay, so we really want to give the yeast the best possible environment to ferment. So usually what we do is we use Ferment K, which is the yeast energizer, and the DAP, which is the yeast nutrient. It's mostly nitrogen. And we add them, and we add the additional nutrient requirements for the yeast during the fermentation. So what we do each time we add the yeast, so for a 20-liter batch, usually we'll use 1 teaspoon of Ferment K, the brown stuff, and 2 teaspoons of diammonium phosphate, which is the white stuff. This should be adequate. We mix them together in a bowl, as we saw. And then we add them using the following schedule. We add, so we have 3 tablespoons, so we add a quarter. So it's going to be 3/4 of a teaspoon of yeast energizer and nutrient mix immediately after pitching the yeast. Then we add the next quarter after 24 hours, the next one after 48 hours, and the last dose after 30% of the sugar has been depleted by the yeast. And each time we do it, we also steer in the nutrients. As you can see, we do a rapid steer. So this rapid steer does 2 things. 1, it gets CO2 outside of the mead. And 2, it adds oxygen, which the yeast need at that stage, okay? Also, if we're making a melomel with fruit, usually the fruit tends to float to the top on the CO2 and stay at the top and make the temperature rise inside the mead. So we want to punch down the fruits from the top, and mixing the nutrients also helps. One piece of advice, if you're going to do that, please be advised, there is a lot of CO2 when you're going to add the last amount of nutrients. And if you use the degasser, please use it slowly. If you will use it rapidly, you will have one hell of a mead must fountain, okay? And everything will be covered in sticky mead must. It happened when I made this mead, and that's why you can see in the previous picture that we started from the top of the stickers, and now we have a lot less must in the fermenter. Okay, so please be careful when you take out the CO2 in the beginning. or you will have a pool of mead must everywhere to clean. So this is about the nutrient additions. And the last thing we're going to talk about is the fermentation management choices. So as with any fermentation, the rule of thumb for fermentation temperature is lower fermentations equals cleaner fermentation. Please use the spec sheets of the yeast strain you used to make the mead and see what is the range of temperature that the yeast work in. The second thing we can do during the fermentation is we can decide if we want to put all of the honey at the beginning, or we can do step feeding. So we can add most of the honey at the beginning and then add more and more honey during the fermentation to achieve higher ABVs. And also, the last thing we need to notice when we discuss fermentation is the length of fermentation. And this can be used to determine the levels of residual sugars we have at the end of fermentation. So if we end the fermentation early, we can create some semi-sweet mead or sweet meads without back sweetening it at the end. So that's it. That is today's presentation. Thank you all for listening.